Hello everyone, my name is Nimish Saxena and today I'll be showing you two cool techniques using the Unity editor as well as shader language called ShaderLab and C# scripting. And these two techniques are simply creating a ripple effect, as you can see here, with this leftmost plane all through shaders, and also creating a scrolling texture effect using C# scripting, as you can see in this right plane. There are many different uses to both of them. For example, a ripple effect could be used as water, or it could be used as drop collisions for many different types of meshes. And the scrolling texture effect could be used for something like a treadmill or optical illusions. And your creativity is really your limit for shaders and textures and wonderful things about game development. So for the first thing I'm going to show you is how to manipulate the vertices of a mesh such as a plane to incorporate a ripple movement. So the first thing you're going to do is incorporate a plane. So you can just create 3D object plane, and I just added a simple texture wood model with the Rust normal map so it shows as show. So the first thing we're going to do here is create a shader. So we're going to go to create and then shader, and we're going to pick the very first shader here, standard surface shader, and call it something like, why not, 490 ripple effect for this wonderful class. So I'm going to open it in Sublime and not in Visual Studio, simply because I think there is a package in Sublime that works better for shaders over Visual Studio, so I definitely recommend it. It's an easy search. It's called Unity Shader Package. So first off, you can change this path if you want to something that you like, in wherever to call the shader from your material. And we also, if you need it, if you want it for looks, I'm not going to use it. We can just take off metallic, glossiness, and color, and remove it everywhere that we see it. So right here, where we initialize it, and also in this function over here. I guess we can delete that too. And Unity might complain about this, so just remove that. It's not going to need it. And so we are also not going to need this full forward shadows as well as the standard Pragma shader from the Pragma directive. So we can use a vertex vert. That signifies that this is going to be a vert shader, and we need a special type of vertex shaders. So we're going to use Lambert functions shaders for that. So the next thing we're going to do here is call various properties regarding of what a ripple effect should have. So some properties is the size, so we can just call that size, and we call it as a float. We can just default equal to 1. Next is the speed. If I can spell speed, we're also going to call that float, and frequency. Also call that float, and we need to initialize it down here. So float, size, frequency, and speed. Just like that. So now we are going to make a vert function, and we are going to use in the parameter inout app data full v. So the first thing we can do is define the y-axis, which will be the extremities of the bumps for this shader, or I'm sorry, for this ripple effect. So we're going to equal that into something called offset, which I will explain. And we will initialize offset as a half offset, which we can equal v.vertex.x. So what that pretty much is the direction of where we'll see this ripple effect go towards. So right now we're not going to have a wave, as we're just equaling it to the x direction. So we are going to add a wave here, a sine wave, like that. And remember your semicolons, you need semicolons here. So to show the result, we need to go to our plane, go down to our material, and go to where we declare the path at the very top, CS490, ripple effect, boom. This is the wave that you see. So how this works is very simple. This offset is the direction, so it goes in the x direction, and you're incorporating the sine wave, which is shown here. There is a sine wave going in the direction of the x direction. And the extremities of the bumps are on the y-axis as shown. So to understand it better, let's say we change this to z, and why not change this to x? Boom. As shown here, the direction of the sine wave is now going down or towards you in the z-axis, and the extremity of the bumps, the size of the bumps, are going into the direction of the x-axis. So we're going to change that now. And this time we are going to incorporate the size, speed, and frequency to show some ripple effects, animated ripple effects. So we're going to incorporate, we can just call it value, why not? And this is going to be the size times the sine wave, the calculation sine wave of the difference in time times the speed plus the direction times the amount of bumps that we will see. And here we don't need to use offset. Did I label it offset? Oh, it's offset. So we will take this out. It looked weird. So now we can take this out because we are going to use it in the value, and we will change this value, which holds all of our calculations. So to show the results, it's a bit choppy, but if we play it, it looks a bit better. So you can see there's a wave going on there, and we can change this if we want. So you can see the size is getting bigger. And the speed. It's getting faster. And the frequency, the waves, almost nothing because it's near zero. And if we go farther away from zero, it goes up. So if you noticed in the past, the wave was also going up and down. So that's because we are using the sine wave twice. We don't need it here in the offset. So we will take that out, and if we go test it, play it to make it show more clearly, boom, the wave is not going up and down, and it is going perfectly in the x direction. But this isn't really a ripple, this is just a wave. So in order to get a ripple, we can specify multiple directions here by timing x with z. So if we show here, and it's going, this is not really a ripple either, but this is showing that, here we can lower some of these, lower the size a little bit, contain it down. So the waves are going in a diagonal in the x and z axis. That's what that timing is for. So let's say, what would happen if we times it by the same axis? It's just like a double sine wave, pretty much, almost. It looks really choppy, it looks like it's paper, not really water. So a way we could potentially show a ripple effect here is if we times this number by the direction that I'm going to go with, which is the z-axis, the offset. So we can play it, and we can mess around with values here and there. We can change the speed to like 1, maybe the size to like 0.25, and that's pretty much how to make a ripple from a shader. You just need to manipulate the directions in this offset and incorporate these into a sine calculation value and have where you want the extremity of the bumps equal to the value. So the next thing I'm going to show you is another piece. It's simpler than you think. It's called scrolling textures. Okay, so the next thing I'm going to show you is something called scrolling textures, and this is not needed to do with shaders. I'm going to show you a simple way of achieving something that looks cool, but it's pretty short amount of lines of code. So first we can just create a new script here, a new C# script. We can just call it, why not, scrolling textures. Then we will open that in Visual Studio. So this is pretty simple. All we need is a public float. We need speeds for the x and or the y-axis to return. So we can use speed x and speed y. It's that simple. And so we don't need the start function at all. We're just going to operate every frame in the update. So we are going to need an offset for both x and y. So we can just call this offset x is equal to the time since the start of play with the speed. And we're going to do the exact same thing for the y. Now this next part, we are going... So my IntelliSense isn't really working too well right now because it is under miscellaneous files, so I would have to drag it and put it back, which is unnecessary right now. So if this ever happens to you, if you get miscellaneous files tab, you can simply just remove it and put it back in the scripts folder, or you can just call it back from the scripts folder and it should reload everything. Just a simple tip. So get component renderer. You're going to access your render, you're going to access the material, and I believe it's called main texture offset, which is literally just the offset of the texture, and you are going to simply equal it to a new vector 2 equaling your two offsets. So let's see how this works. And of course attach it to your texture plane, make sure it's there. Okay, cool. So we can assign values such as, let's say 0.5, 0.5, why not? Let's see what happens here. Boom. So this looks especially cool because it's a gradient and it looks like a loading bar. It looks like something you can load. So there's many practical uses for something like this. For example, we can change the speed to 0. See what happens. It's just slower. We can. So using a gradient isn't the best example because you can only see the gradient from the Y perspective. That's just how the texture is. Let's say I changed this gradient into something like this, the texture we had before. in our shader example. As you can see here, it is going crazy on the x-axis because the speed on the x-axis is insane. But let's say we want to make this 0 and it's on the y-axis. So there are multiple uses for something like a scrolling texture. If you want maybe doing a treadmill effect or a loading bar effect like how I showed with the gradient, there's many uses to this. Just be creative. And yeah. So thank you for listening to my tutorial about scrolling textures and rippling through shaders. I thank you. So definitely some cultural and legal issues here are simply copyright. If you use someone else's textures, make sure to credit them as their own textures. These wooden textures I got from a website called textures.com. They give 15 free textures every day if you sign up, so it's very useful. Go check them out. And that's really the only textures I got. I made the gradient myself on Photoshop to show you, but the gradient was not the best example. So that's definitely a legal issue that you could run into. And if you want to reach me, you can reach me on my LinkedIn, Nimish Saxena, or you can reach me on my email at nimishsaxena96@gmail.com. Thank you very much.